This question is called dice order, and it says we throw 3 dice one by one. What is the probability that we obtain 3 points in strictly increasing order? So, actually, I was asked this question almost verbatim, except 3 dice it was 4, and it was for Citadel for quant trading. So it's a very relevant question, important to understand. So if we have 3 dice, one ordering that's successful can be 1, 2, 3. That counts as a successful ordering because it's strictly increasing. Right, strictly increasing order. If we had 1, 3, 3, that is no longer strictly increasing. From one point to the next, we increased. From one point to the other point, we did not increase, we stayed the same. So that was not a strictly increasing order. So that means we're going to have unique numbers every single time. And for unique numbers, now we enter the realm of combinations and permutations. So now we can scratch the idea of dice and enter the world of combinations and permutations given 6 total numbers and a size of 3 choosings or 3 permutation, like 3 size window. So a permutation is a distinct, unique arrangement of numbers. And we're going to say of 6 numbers and how many different 3-sized, distinct, unique arrangements we can create. So we can have, for example, one permutation. So like it was like 6 NPR or something in the calculator. It was 6 NPR 3. One distinct, unique arrangement of 3 numbers from 6 is like 1, 2, 3. Another one is 1, 3, 2. We can have 2, 3, 1, 2, 1, 3, 3, 1, 2, and 3, 2, 1. If you notice, so we have, using the same 3 numbers, we created 6 distinct unique arrangements of them. If you noticed, one of these permutations was one such that we were in increasing order. So if we could find a way so we're trying to find, obviously, probability. We're going to find number of increasing sequences over total number of sequences. That's how we solve this question. I'll write that much better. So we're trying to find this part first. The permutation function is like number of options factorial divided by size factorial. So that's 120. If we could somehow, the number of increasing orders is how many permutations we have, but just one of the permutations we care about. Luckily for us, the combination function, 6 NCR 3, or aka 6 choose 3, is just the number of is a distinct a distinct unique choosing of 3 numbers. So we're still going to have unique numbers. So no 1, 3, 3, 3, 3, 3, 3, 3 is not allowed. 1, 3, 3 is not allowed. 1, 2, 3 is allowed. But 1, 2, 3 represents all the orderings. So, for example, one of the choosings is 1, 2, 3, which equals 1, 3, 2, which equals etc. So the choose function is just telling us we don't care about the orderings, we care about the numbers we chose. By saying this, it's like saying we care about one permutation, we can scratch the rest. So it's like saying, oh, we have all these possible ways to choose the 3 numbers in their orderings. Pick one ordering arbitrarily, it doesn't matter, and scratch the rest. That's what it's saying. When I say 1, 2, 3 is our combination we chose, now we're not going to include 1, 3, 2 anymore. They equal the same. We could have said we're going to pick 1, 3, 2 and then move on to the next. But that's still, it's arbitrary. So you can pick whatever you want. But that's going to be our choosing of those particular 3 numbers. Remember, our goal was to find a way to represent just one of the permutations, and choose does that for us exactly. The number of combinations is equal to the number of increasing sequences. So here, we can replace that with number of combos or combinations over total number of sequences. Again, it's very important to understand the number of combinations is the same as the number of increasing sequences, because combination neglects order, and therefore combination, it represents just one permutation for its whole choosing of those three numbers. And what we're trying to find for this question is one permutation exactly, the one that they're all increasing. We could have said all decreasing as well, and that would have worked too, the number of decreasing numbers and that or sequences. That would have been the exact same question, because now we just care about this permutation instead of that one. So I'm trying to hammer the whole point, because that's like the whole point of this question, because the rest of it is just very simple arithmetic, or just solving arithmetic. Now 6 choose 3, which represents the number of increasing sequences, over what is the total number of sequences we can have? Well, we can have 6 numbers the first time, 6 the second time, and 6 the third time for each dice roll. So we can have 6 cubed different sequences. And 6 choose 3 is 20, and 6 cubed is 216. And just by the way, 20 means we can there's 20 ways to choose any 3 numbers from 6. We could choose, whenever we pick 3 numbers, we can make sure that we choose the increasing ones, if that's how if you want to imagine like that. So 20 ways to choose only increasing sequences, or 20 ways to choose any 3 numbers. Same thing here, over 216, and that's going to be 5 over 54, and that's the answer.